Woo! Alright, welcome period 9. You are watching this because you missed class yesterday because you were either freezing in the field or you were like chilling at Santucci's or whatever because of fake bottles. Good. We're going to have an extremely fast introduction to counting. This is something that you probably have not been directly instructed on, like within school, although maybe so in like middle school or something, I'm not really sure, depending on what middle school you went to. But this is definitely a thing that comes up a lot in like math teams, so a lot of you might like know this, or whatever. Good. Okay, so counting. So the simplest thing is like this. Suppose I am I'll just use myself as an example. Suppose I'm getting dressed in the morning and I have precisely 4 shirts. And I also have precisely 3 pairs of pants. And I have 2 pairs of shoes. This is not so inaccurate. Well, how many possible outfits do I have? Assuming that all my outfits go together nicely and stuff. Well, I can think of this as a decision. I have 4 shirts, so first I'll choose which shirt to wear. 4 choices, yeah? Then having chosen which shirt to wear, I will then choose which pair of pants to wear. And so for each choice of shirts, intuitively I have 3 choices for what pair of pants to match with that. And finally, I have 2 pairs of shoes, so for every one of those shirt pants combos, I can further pick a shoe choice. And so every distinct path through this decision tree is a different possible outfit. Follow? How many outfits do I have therefore? 24. Woo woo! Okay, good. Some people call this the fundamental principle of counting, or the multiplicative principle. Basically what it says is, I'm just going to say it out loud, because I don't feel like writing it down. If you have independent decisions to make, and you have A ways of doing thing 1, and you have B ways of doing thing 2, then you have A times B ways of doing both of them. Cool? Okay, cool. Alright, and this principle is applied intuitively all the time. For example, suppose you are picking a license plate for your car, 3, 4, 5, 6, 7. And suppose you are in a state like, say, Maryland or whatever, where you have 7 digits, or 7 characters rather, in your license plate, and you're going to pay whatever, it's $100 or something to get a vanity plate to be something cool, something I've considered doing for myself. And you have to therefore make some choices. Well, how many possible choices are there, assuming no other restrictions? How many choices do I have for character 1?
36.
36, right? Because 26 letters of the English alphabet, and then 10 digits 0 through 9. How many choices do I have for the second character?
36.
Also 36, because it's independent, right? And so 36, 36, 36.
That's a lot of 36.
It really is. So how many total possible license plates are there, assuming none are forbidden because of profanity and things like that?
36.
36 to the 7th, right? Woo-woo. Okay, good. All right, let's just skip right to where it starts to get interesting. Okay, suppose you have 4 letters, A, B, C, and D. And I would like to permute these letters to write them in some kind of arrangement. Well, I can do A, B, C, D, or I can do A, B, D, C, or I can do A, D, B, C, or I can do A, D, C, B, etc. How many ways are there to do this?
24.
Let's just talk it out instead of listing, because listing them all seems like this would be really tedious, right? And would take a while. Instead, let's use math to solve this problem for us. I really have 4 choices. So how many choices do I have for what letter to come first?
4.
4 choices. How many choices do I have for which letter to come second then? 3. How many choices do I have for which letter to come second? To come third? 2 choices, and then I just really have 1 choice. And so this is just 4 factorial. And in fact, we call this a permutation. And so fact there are n factorial ways to permute a set of n objects. Cool? Say cool.
Cool.
Okay, good. You could almost even take that as like the definition of n factorial or something maybe, but okay. All right. Now, sometimes it gets more complicated, however. So suppose, oh boy. Okay, so suppose you are, you have 7 classes, and let's call those 7 classes A, B, C, D, E, F, G. So this could be, we don't have time to have fun, so I'll just call them out as like, you know, algebra, biology, chemistry, Dutch, entomology, French, and German. Good. Very language-heavy program. So you have 7 classes and you have 7 textbooks, and you are on the bus on the way home, and you have high hopes for yourself. Every day is a new day. Today I'm gonna like be responsible, exercise, eat right, do all my homework, tell my parents I love them, go to bed at 9:30. So you're planning all of the ways you can do your homework, and the order that you do your homework matters, because you don't want to like, you know, do your Dutch homework, you know, last, because it requires a lot of focus and stuff. So anyway, how many ways are there to complete all 7 homework assignments? 7 factorial ways, right? Which is a very huge number. Okay, good. That's scenario 1. All right, now scenario 2, unfortunately, might be more accurate. In which case, you go home, you play video games, you play on Twitter, you just like, you know, just like waste time, and then suddenly it's like 9:30, and you're like, I haven't started my homework, and now you realize, man, I have only time to do 4 out of these 7 assignments. So you're just going to cut your losses, and just 3 of them are just not going to happen. So, okay, question. How many ways are there to complete just 4 of these 7 assignments?
7 factorial divided by 3.
Let's just talk it out.
No, because that assumes that you're...
Wait, I got this. So let's just talk it out. I have 4 classes I'm going to do. That's all I'm going to do. So how many choices do I have for what to do first? 7. Everyone agree? How many choices do I have for what to do next? 6. How many choices next? 5 and 4. So that's just clearly the answer, right? 7 times 6 times 5 times 4. And then the rest, the other 3 classes just don't get done. Okay, so while that's the answer, it's possible to like write this out a little bit more clearly as 7 factorial divided by 3 factorial. Yeah, and in general, this sort of explains some kind of like a truth or something. That which I got no talking Oscar. Good. So the way you can think. So okay. So this idea can be sort of more generalized. Suppose if I have n objects, then we say that there are npk, pronounced n permute k. Yes. Is the number of ways to permute, in other words, to put in some kind of order, k of the n objects. What we have just sort of seen, I guess, by this example, is that npk is n factorial, but then you divide out by the ones that you left behind. Yeah, those of you who maybe have seen this before, you see that this is kind of the formula. All right, well, to make this kind of make sense a little bit, think about what happened on the way home when you were still planning on doing all the problems. When you were still planning on doing all the problems, you had maybe like A, C, F, G, and then like B, D, E, right? That was one of the many, many ways you were planning on doing your homework. Well, there's also the A, C, F, G, B, E, D way. And there was also the A, C, F, G, D, E, B. And also the D, B, E. And also the E, B, D. And also the E, D, B. Okay, and those are 7 different ways that you could, okay, never mind. These are the 7 different ways that you could have done your homework back when you were planning on doing them all. Don't say anything. Okay, well, now we're not going to do the last 3 homeworks, right? So if we're not going to do the last 3 homeworks, all of these 6 ways, these were 6 individual distinct items on the original plan, right? They have now collapsed into just one, right? Now this should just get listed once intuitively, because ACFG is just one way. And so one way to think about this division is, you're taking the entire extended original list of 7 factorial, and you're dividing by 3 factorial. Why? Because your original list was, for our new problem, 3 factorial too long. It was too long by a factor of 3 factorial. And what is this mysterious 3 factorial?
6.
It's 6, right? It's the 6 ways there were to permute the classes that never got done. Okay? So the deep way of understanding this formula is to say, okay, take all the ways of permuting k of the n objects, and then multiply by n minus k factorial, which represents the ways of permuting the rest of them, right? And if you permute the k that you want, and then you also permute the rest of them, then that is like the entire permutation. Follow? So I think this is like the deep fact, and this is like the formula. Okay, good. One more to go. What if now, instead, you're just not even gonna care about the order anymore? Now you're just like, come on, man. I just want to get this done with. I just want to do 4 of my classes. So now we have this symbol 7 choose 4. This represents the ways of just picking 4 out of the 7 books to just do. Okay, well, intuitively now if I don't care about order, now A, C, F, G, and A, F, C, G, and A, G, F, C, and etc. Now all of these with different ways are all now considered the same way, right? Because the order in which I do the assignments doesn't matter. So I need to further divide this list. How much do I need to divide by?
4 factorial.
4 factorial. Because this list, there are 4 factorial ways to organize these 4 homework assignments, but now I don't care about the order anymore. So this 7 choose 4 is 7p4, but I also divide by 4 factorial. Because this new list should be shorter by a factor of 4 factorial. And in general, we say that n choose k, this is the cool way of writing it, but lame people also write it like nck, which is what our textbook does, is just the number of ways to choose k objects, one more minute, from a set of n objects. From a set of n objects. And in general, what we have seen is that n choose k is just npk divided by k factorial. And the deeper understanding of this, in my opinion, is to think of it as a multiplication problem, right? N choose k is the number of ways given n objects of picking k of them. After you've picked those k objects, then if you order those k objects, then what you get is the number of ways of permuting k objects. And therefore, since this is the way of thinking about it, first choose your k objects from your set of n objects, then order them. Well, that gives you the number of permutations. And therefore, by dividing both sides by k factorial, you get this formula, which is really like n factorial over n minus k factorial over k factorial. And so the formula that you see in textbooks is like this one. All right, that was a very fast introduction to counting. Goodbye, period 9. Woo!
Okay.